Okay, I promised you a trig review, so that's what we're about to do. Okay, now I'm kind of assuming that you know trig. Remember, that's a prerequisite. So this is going to be a really quick kind of zip through to remind you so that it'll give you some help maybe with that algebra trig review. And then remember, you can ask anybody on campus. I love trig, so it's going to be on every test. So if you need extra help after this, you're going to kind of come see me one-on-one. Okay. Now, some of you know trig kind of from the unit circle, okay? Now, on the unit circle, all I'm going to talk about, the unit circle is a circle whose center is the origin and the radius is 1, okay? So if this is your unit circle, if this is your center and that's the origin and the radius is 1, then what's that point? That radius is 1, so that'd have to be 1, 0, okay? What would this coordinate have to be if that radius is 1? This is on your y-axis. Okay, make sure that that's 0, 1. And this time it's a radius of 1, but you know we're going to the left, so that's going to be negative 1, 0. And then this radius is 1, but you're on the y-axis, so that's 0, negative 1. Now, that's really all about the unit circle that I messed with. So if you learn to do trig with the unit circle in high school, you're welcome to use the unit circle, but you got to have it memorized. So what I'm going to do instead is I'm going to use the special triangles because that's what people use to build the unit circle. And when I was in junior high, I had to memorize those special triangles. So I already had that memorized, so why would I waste the brain space? Okay, so you're welcome to do it either way, but you can't have a sheet of paper out with the unit circle on it. You'll have to memorize it if you want to use the unit circle. Now, let me remind you about a couple of things. All right, cosine theta is x over r. But now if you're on this unit circle, since your radius is 1, that r is going to be 1. So x over 1 is just x. So cosine on this unit circle is just your x coordinate. That's what's sweet about the unit circle. Sine of theta is y over r. But again, because your radius is 1, that r is just a 1. So sine of theta on that unit circle is just y. Tangent, remember, is sine over cosine. So since sine was y and cosine was x, tangent is just y over x. Now remember, there are 3 other trig functions that are the reciprocals or the flips of these. So instead of cosine theta being x, and since cosine of theta is x over 1, secant of theta, let's put theta here instead of x's since I use theta over there. Secant of theta is going to be the flip or the reciprocal of that, so it's going to be 1 over x. Similarly, since cosecant is the reciprocal of sine, since sine is y, cosecant is going to be 1 over y. And since tangent of theta is y over x, sine over cosine, then cotangent is the reciprocal of that, so cosine is going to be x over y. Now remember, I told you in the front flap of your calculus book, there's a trig review sheet. If you flip over 1 page, it's on the back of that first formula sheet page. So all this information right here is there, but hopefully you already know this. Now, another way of looking at cosine, remember, if you've got a triangle, then remember cosine is going to be your adjacent side over your hypotenuse. I'm just kind of abbreviating that. Sine of an angle, when you're looking at triangles, is going to be your opposite side over your hypotenuse. Okay? And tangent, remember, on a triangle is going to be your opposite side over your adjacent side. Okay? So cosine is adjacent over hypotenuse, sine is opposite over hypotenuse, and tangent is opposite over adjacent. Now remember, these 3 basic trig functions have reciprocals. Remember, reciprocals mean you flip it, okay? Remember what we said over here, the reciprocal of cosine is secant. So if cosine is adjacent over hypotenuse, then secant would have to be what? That's right, it'd have to be hypotenuse over adjacent. Since cosecant is the reciprocal of sine, then we'd have to flip that one or take the reciprocal. So cosecant would be hypotenuse over opposite. And then since cotangent is the reciprocal of tangent, instead of having opposite over adjacent, for cotangent you have adjacent over opposite. Now, one thing you might want to do is you might want to freeze the video right now and then copy that down if that's not something that you already know. Okay, that information's on that sheet, that reference sheet, but like I said, you might want to copy it down in your notes so that you'll have it. Hopefully you can read that. okay? Now what I do is I use the special triangles. Now remember the special triangles that you had were 30, 60, 90 degrees and 45, 45, 90. So let's review. On a 30, 60, 90 degree triangle, the side across from the 30 is a 1. The side across from 60 is the square root of 3 and the hypotenuse is 2. Now that's a memory trick, sort of, to remind you that, remember, now think about it. Common sense will tell you this. If this is my angle and this is the side across from it, does it make sense when I widen the angle that the side across from it would get longer? So that's why the longer side, the square root of 3, is across from the bigger angle. So that's a way to remember that. But this is your short leg. Remember the two sides where the right angle is formed are your legs. The side across from the right angle is your hypotenuse. So the side across from 30 is your short leg, and your long leg is the square root of 3 times your short leg. And then your hypotenuse is double your short leg. So if this is 1, that turns into a 2. So you need to memorize that if you're going to use triangles. Now 45, 45, 90, remember your memory technique is the legs are the same. You know, sides, opposite, congruent angles are also congruent, and they're both 1, and then your hypotenuse is the square root of 2. Now these are close enough to be dangerous. This hypotenuse is 2, this hypotenuse is the square root of 2. So again, you might freeze the video and copy down your special triangles if you don't remember them. So you can either memorize these triangles or memorize the unit circle, kind of your pick. Now, I'm going to kind of show you some trig in quadrant 1 off of these special triangles. So you got this in your notes, so you might want to put it next to you when I go over this. Now, as a reminder, remember that 180 degrees is the same thing as pi radians. Now, this whole semester, they're going to do radians. They never really do degrees. We'll talk about why in class, okay? So if they give you radians, a lot of people are more comfortable thinking in degrees, so you can switch it to degrees to do the work if you prefer, okay? But answers have to be in radians if they want angle measures. Now, let's talk about some basic trig in quadrant 1. So suppose on your first test, I asked you for the cosine of pi divided by 3. Now again, that's in radians. If you think better in degrees, then pi radians is 180 degrees. So if you want to change it to degrees, that pi can be changed to 180. Now what's 180 divided by 3? That's right, that's 60 degrees. So I want the cosine of 60 degrees. So which of these triangles has a 60 degrees in it? That's right, the 30, 60, 90. So I want the cosine of 60. So my 60 is up here. And remember what cosine is. Look back at your notes if you need to. That's adjacent. That means right beside it over your hypotenuse. So the cosine of 60 degrees is going to be 1 over 2. Now, what if they wanted the tangent of pi divided by 6? Now again, if you think better in degrees, then change to degrees. Pi is 180 degrees, pi radians, so 180 divided by 6 is 30. So the tangent of 30 degrees. So go back up to your 30, 60, 90 degree triangle and find your 30. Now remember, what's tangent? Tangent is opposite over adjacent, so 1 over the square root of 3. Now, this is fine with me. If you want to rationalize it, we'll talk about that in class. If you would rather multiply the top and bottom by the square root of 3, sometimes in high school they make you do that. If you want to put the square root of 3 over 3, that's fine with me, but I'm going to leave it at 1 over the square root of 3. We'll talk about in class why people rationalize it's important sometimes and not necessarily so important other times. Okay? Suppose I wanted the cosecant of pi over 4. Now, not equals, the cosecant of pi over 4. And again, you can take your calculator. 180 divided by 4 is 45. So I want the cosecant of 45 degrees. So now instead of being on this triangle, I'm down here on this one. Now, you can use either this 45 or that 45, you know, it won't matter. So remember what cosecant was. Cosecant was hypotenuse over opposite. So that's going to be the square root of 2 over 1. which of course is the square root of 2. Okay, so if you're in quadrant 1, you just use the definitions that are written on the board, and you have to worry about whether it's an adjacent side, whether it's an opposite side, or whether it's hypotenuse, and make sure you get the right one on the numerator and the right one on the denominator. Okay, so quadrant 1 is pretty simple. Now, what happens if you're outside of quadrant 1? Well, now I'm going to flip over to this other board and kind of show you something. Okay. Now, you might need to freeze and copy this down. If you're in quadrant 1, your given angle is the same as your reference angle. They're the same. Okay? But now, if you're in quadrant 2, your reference angle is 180 degrees minus your given angle, or pi minus your given angle, if you're in radians. In quadrant 3, your reference angle is your given angle minus 180. And in quadrant 4, your reference angle is 360 degrees minus your given angle. Okay? And that's just a reminder again that pi radians is 180 degrees. So you're welcome to work in degrees if you think better in degrees. Okay? Now, like I said, you might want to freeze the video and copy this down because I'm about to flip you from this board back to that other board. Okay? So if this is beside you, I think it'll make a little more sense. All right, so let's go work some things that are not in quadrant 1. Now I'm going to leave my special triangles there, and I'm going to erase this. So suppose instead I said, okay, what's the sine of 2 pi over 3? Okay, or suppose I said, what's the secant of let's see, what could we do? Instead of doing like 5 pi over 4. Okay? So we need to know what quadrant we're in. All right? So if you think better in degrees, then go change to degrees. Remember what we said, pi is 180. All right? So 2 times 180 is what, 360? And 360 divided by 3 is 120. So I really need the sine of 120 degrees. Now, what quadrant is 120 degrees in? All right, do you remember? This is quadrant 1, okay, 0 to 90. This is quadrant 2, so that's 90 to 180, or pi over 2 to pi. All right, quadrant 3 is going to give you from 180 to 270. And then quadrant 4 is going to give you from 270 to 360. Now in radians, remember it's 0 pi over 2, pi, 3 pi over 2, and 2 pi. Okay? So one thing you're going to have to do is, here's what you're going to do when you're outside of quadrant 1. Your answer is going to be made up of 2 parts, a number and an SIGN, like a positive or a negative. The quadrant tells you whether it's positive or negative. And then the reference angle tells you the number to put with that. Now, after doing this for years and years, I find most people are better off putting the sign, like whether it's positive or negative, the SIGN first, then putting the number answer on it. So let me show you what I'm talking about. 120 degrees. What quadrant is 120 degrees in? All right, quadrant 2. All right. Now remember, in quadrant 2, we've got to find our reference angle. Now go back and look at your notes. Your reference angle in quadrant 2 is 180 degrees minus your given angle. Okay? So our given angle was 120. So 180 minus 120 is 60. Okay? So we're going to need to work with this 60 degrees. Okay, that's going to give us the number part. The quadrant tells us whether our answer is positive or negative. Okay, so if I'm trying to find the sine of 120 degrees, all right, now does sine depend on x or y? Remember in your notes, sine depends on y. Well, if you're in quadrant 2, look what happens. You have to go left. That means your x value is negative, but you go up, so your y value is positive. So do you understand that your x's are negative and your y's are positive? Well, since sine depends on y and our y is positive, our sign here is going to be positive. Now, how do we get the number part? By this reference angle. So what we're really going to do is take the sine of 60 degrees. Okay, so go find 60. Remember what sine is. Sine is opposite over hypotenuse. So we get the square root of 3 over 2. So that's going to be the sine of 2 pi over 3. All right, let's do another one. Okay. What if I want the secant of 5 pi over 4? All right, if I want the secant of 5 pi over 4, then the first thing I'm going to do is I got to figure out what quadrant I'm in. All right, so 5 pi over 4, I'm going to basically say 5 times 180 and divide by 4. All right, now you understand that when you do that, you're going to get 215 degrees. Okay, so what quadrant is 215 degrees in? All right, you understand that's in quadrant 3? All right, well in quadrant 3, look at your notes, your reference angle is your given angle minus 180. Instead of 180 minus your given. Well, your given angle is 215. I'm sorry, it's not 215, it should be 225. Helps if I can do it correctly. I don't do it well in my head sometimes. I don't have my calculator with me, so you double check me and make sure that I'm doing them right. So 225 minus 180 is going to give me 45 degrees. So my reference angle is 45 degrees. So the secant of 225, first I'm going to find the SIGN. Is it positive or is it negative? Now remember what secant was. Secant was the reciprocal of cosine. Okay? Since cosine depends on x, remember secant was 1 over x. So if you're in quadrant 3, you go left and then down. So your x coordinates are negative and your y coordinates are negative. So if you're in quadrant 3, since your x is negative, your cosine is negative. And since secant is the flip of that, secant would also be negative. So my answer is going to be negative. Now how do I get the number part? I do the secant of this reference angle. So I need to know what the secant of 45 degrees is, and I'm going to have the opposite of that. Well, here's 45. Remember what secant was? It was hypotenuse over adjacent. So the square root of 2 over 1 is going to be the square root of 2, but remember it was negative. Okay? All right, let's work a couple more to make sure that we're okay. And again, if you want to freeze the video and copy this down, that might be helpful for you. Okay? All right, let's do another one. What if instead we needed maybe the cotangent of something like, let's see what we might need. How about the cotangent of, let's see, maybe like 5 pi over 3? Okay. Now remember, if you think better in degrees, 5 times 180 divided by 3, isn't that going to be, what, 300? Now, how do I do that in my head quickly? I did 180 divided by 3 and got 60. And then 5 times 60 is 300. Now, what quadrant is 300 degrees in? Remember, that's 270 to 360, so I'm in quadrant 4. All right, remember the little formula over there. Quadrant 4 is your reference angle is going to be 360 degrees minus your given angle. So I need 360 degrees minus 300 degrees, so my reference angle is going to be 60 degrees. So my reference angle is 60 degrees, okay? So I've got to decide what my SIGN is first. Now remember, if I'm in quadrant 4, I must have gone to the right and down from the origin. So if I go to the right, that means my x coordinate's positive. If I go down, that means my y coordinate's negative. So the x or the cosines are going to be positive. The y's or the sines are going to be negative. Now remember what cotangent is. Cotangent is cosine over sine. So if you have a positive divided by a negative, that's going to make the fraction negative. And how do I get the number part? I do the cotangent of this reference angle, the cotangent of 60. Okay, keep my negative. Now go back up here. Here's 60. Remember what cotangent is. Cotangent is adjacent over opposite. Okay, so I'm going to have a 1/2. Okay, so a -1/2. All right, so hopefully that'll make sense. So if you want to do, when you're given the angle and you want to find the trig value, you just really quickly sketch out these triangles that you memorize. First, write down whether the answer is positive or negative, and the quadrant tells you whether the answer is positive or negative, because you should know the SIG ends in the quadrants. Remember, everything in quadrant 1 is positive. Okay. In quadrant 2, the x's are negative and the y's are positive. In quadrant 3, x and y are both negative, and in quadrant 4, x is positive and y is negative. So the quadrant tells you the SIG end, whether your answer is positive or negative. Put it first so you don't forget. Then find your reference angle using those formulas that I wrote on the board. Okay? If you're in quadrant 2, that reference angle is 180 minus your given angle. If you're in quadrant 3, your reference angle is your given angle minus 180. And if you're in quadrant 4, it's 360 minus your given angle. So then you do the trig value for that reference angle. So that sends you to one of those triangles to get the numerical part. So when you put the SIG in with the numerical part, you've got your trig value. So on your review sheet and the rest of the time, when I give you, and I don't want decimal approximations off the calculator. So if the answer comes out to be the square root of 3, do not give me a decimal approximation. I need the square root of 3. So I want exact answers, not decimal approximations. Okay? Now, that's when I give you the angle and I want the trig value. Now, the only time that those triangles are going to fail you is when you've got multiples of pi over 2, like off of this unit circle. Now, what do I mean by that? I mean, if I gave you this, what's the sine of pi over 2? Or what's the tangent of 3 pi over 2? Now, that's actually on your axis. Remember, pi over 2 is 90. Okay? So at 90 degrees, you're right there. Okay? So the sine, remember, on that unit circle is just your y coordinate. So what's your y coordinate right there? It's just 1. Okay? Now, what if it wanted cosine of pi over 2? Well, remember, cosine is just your x coordinate. So what's your x coordinate right there? It's just 0. Now, what's 3 pi over 2? Isn't that 270? So if I'm at 270, now I'm right here. Now, remember what tangent is. Tangent is sine over cosine, or y over x. But right here, if you put a -1 over 0, remember that's undefined. So the tangent of 3 pi over 2 is undefined. Now, the cotangent of 3 pi over 2 would be x over y. And 0 over -1 would be 0. So cotangent of 270 is 0, but the tangent of 270 is undefined. That's why I remember when you were doing the graphing on your trig for tangent, how you had those S-curves and you had those vertical asymptotes. These are where those vertical asymptotes occur when you get undefined. Okay? So that's how you, when you're given an angle, how you find a trig value. Now we're going to flip it. All right? What if instead I give you what you think of as the answer and I want the angle? Okay? Well, then you need to build the triangle. Okay, let's get a marker that writes a little bit better. So this, you're given the trig value, and you're told to find the angle. Okay, now we're going to do quadrant 1, and then we're going to get out of quadrant 1. All right, so your first step is you build the triangle, and you'll see what I mean by that in a second. Okay, so you're going to build the triangle first that makes that trig. All right, and you're probably going to have to find a missing side using the Pythagorean theorem once you do this. Okay, and then you're going to need to find the reference angle. Then you're going to have to find all the angle measures that make that true. Now you'll see what I mean in a second by that. All right, so what if I told you this? What if I told you that the cosine of some angle, okay, was the square root of 3 over 2? And I want to know, what is theta? What's the angle? I want to know what the angle is. Now, remember what cosine is in words. Cosine is adjacent, so that must be my adjacent length over my hypotenuse. So that must be my hypotenuse. So I build a triangle. So I come over here, I build a right triangle. Out of habit, I always put theta there. You don't have to, you can put it up here if you like it better, but just be consistent. Now remember what cosine is. Cosine is adjacent. So what side is adjacent to this one? It's going to be this one, isn't it? So that's got to be the square root of 3. Hypotenuse is across from the right angle, so that's got to be 2. Now, what's that missing side? Now, isn't that a right triangle? Okay, because that's a right triangle, remember you got Pythagorean theorem. A leg squared plus a leg squared is your hypotenuse squared. Okay, so one of your legs is the square root of 3. I don't know what the other one is, but my hypotenuse is 2. Okay, so I get the square root of 3 squared is 3. Plus b squared is 4. So b squared is going to be what? 4 minus 3. And what's 4 minus 3? Isn't that 1? Now, what is b? If b squared is 1, do you see that b is a positive or negative 1? But now this is a length, and a length can't be negative. So that negative 1 doesn't make sense in this context. So I know that that missing side is a 1. So you're going to have two sides given, Pythagorean theorem, you find that missing side using it. Now, as soon as you see these numbers, it should pop in your head, oh my goodness, that's a 30, 60, 90 degree triangle. Well, on the 30, 60, 90, remember we talked about what's across from the 1? Is that the 30 or the 60? Do you remember that's the 30 degrees? Now, so my reference angle is 30 degrees. Now, remember what I told you, we don't use degrees, we use radians. So it's got to be 180 divided by something. What do you divide 180 by to get 30? Your calculus students, we can do arithmetic. Do you see that it's 60? And then we don't use 100, we don't use degrees, so we're going to change that 100 degrees to pi radians. So my reference angle is 30 degrees, if I can do this correct, or pi over 6, okay? Because pi, 180 divided by 30 is 6, not 60, okay? So there's my reference angle. So one of my answers is pi over 6. Now, here's why. Isn't this a positive number? Okay, where is cosine positive? Now remember your unit circle. Everything's positive in this quadrant. Here, your x's are negative, your y's are positive. Down here, x's and y's are both negative. And over here, you go to the right, and then you go down. Okay? So, remember what cosine depends on. Cosine depends on x. But where is x positive? In quadrant 1 and in quadrant 4. So, I've got to have both of those answers. Okay? So here's my quadrant 1 answer, 30 degrees or pi over 6. But see, I still need a quadrant 4 answer. Now remember what we know in quadrant 4. In quadrant 4, our reference angle is 360 degrees minus our given angle. But this time, instead of knowing the given and wanting the reference, I know the reference and I want the given. All right? So 30 degrees is 360 degrees minus something. All right, so again, if I add x to both sides and subtract 30 from both sides, does that make sense? This one comes over there and that one goes over there. I'm going to get 330 degrees. But I can't have it in degrees, I've got to have it in radians. Now, to me, the sweet thing about it is this angle is always going to be a multiple of this one. So what do you multiply 30 by to get 330? okay? Everybody okay? All right, so see if you can figure that out for me. All right, so if I do, let's see, what's 11 times 30? Isn't that 0? Isn't that 330? All right, so 11 times 30. So my angle's 11 times 30. But now what was 30? 30 was pi over 6. So I get 11 pi over 6. So my two angles are pi over 6 and 11 pi over 6. Okay? All right, let's do one more real quick. Okay. And hopefully this will be enough to get you started on that review sheet. Okay. All right, what if I told you that the tangent of some angle was a -1 over the square root of 3? All right, a -1 over the square root of 3. Now, you got to decide what two quadrants your answer's in, okay? Does tangent depend on x and y? So when would a fraction be negative? It wouldn't be when they're both positive, and it wouldn't be when they're both negative. It'd have to be where one is positive and one is negative. So does it make sense to you that one of your answers is going to be in quadrant 2, and your other answer is going to be in quadrant what? 4. Okay? Because for a fraction to be negative, either the numerator or the denominator has to be negative, and the other one's got to be positive. Okay? Now, I've got to find my reference angle first, remember. So what do? We build the triangle. Okay, so I'm going to build this triangle. All right. Now, remember what tangent is. Tangent is opposite over adjacent. Okay? So the opposite side must be 1, and the adjacent side must be the square root of 3, and I don't know what that is. Okay? Now, don't ever put a negative on the length of the side of the triangle. That negative tells me what quadrants. That negative tells me I was in quadrant 2 and 4. So I'm not going to take time to do Pythagorean theorem because you're a calculus student. So you do it and you figure out that this hypotenuse is a 2. So again, that's a 30, 60, 90 degree triangle, and the side across from the 1 is going to be a 30 degree. Okay? Now, that's my reference angle, but I need a quadrant 2 angle and a quadrant 4 angle. So I know that my reference angle is 45 degrees, which is 180 divided by something. So you take your calculator and figure it out. That's going to be 180 divided by what? Oh, I'm sorry, not 45, I mean 30. My reference angle is 30. So again, does it make sense that I'm going to have pi over 6? Okay, but this time I need quadrant 2 and quadrant 4. So remember what we know about quadrant 2. In quadrant 2, our reference angle is 180 degrees minus our given angle. So our reference angle is 30. So 180 degrees minus something gives me 30. What do you subtract from 180 to get 30? You understand it's 150 degrees? Now, remember what I told you, the lovely thing is, this one is always going to be a multiple of your reference angle. So what do you multiply 30 by to get 150? Okay, don't you multiply 30 by 5? But remember, what is 30 degrees? 30 degrees is pi over 6. So I substitute pi over 6 for 30. So my quadrant 2 answer is going to be 5 pi over 6. Okay, and again, you can always freeze the video and write these down. How do you get quadrant 4? Well, I'm going to go use my quadrant 4 little formula. Okay, so in quadrant 4, my reference angle is 360 degrees minus my given angle. Okay? So my reference angle is still 30. And again, 30 is 360 degrees minus something. So solve that for x. So do you understand that x is going to be 330? And what we said, that's going to be something times this reference angle up here. Well, what do you multiply 30 by to get 330? Remember we said a minute ago that would be 11? So again, I know that 30 degrees is pi over 6, so I substitute pi over 6. So I get 11 pi over 6. So that's going to be my quadrant 4 answer. 11 pi over 6. Okay. All right, let's do one more. And then hopefully we'll be okay. All right, what if I told you this? Okay. The tangent of some angle is a -1. Now, first of all, I need a fraction. Okay, how can you make tangent negative? All right, excuse me, how can you make a -1 a fraction? Can't you always put it over 1? I tell you what, let's make it, that's all right. We'll do it like this. All right. So again, where is tangent negative? All right, well, tangent's going to be negative when the signs are different. So again, it's going to be 2 and what? 4. If I said tangent of some angle is 1, again, you have to have a fraction. How do you make a single number a fraction? You put it over 1. So if I said tangent of theta is 1, the signs would have to match. So on this one, I would be in quadrants 2 and 4. On this one, I'd be in quadrant 1, but look where else I would be. I'd be in quadrant what? 3. Because a negative divided by a negative is a positive. So how about if we work this one, since we did a negative one over there a minute ago? So I'm going to build my triangle. Now remember what tangent is. Tangent is opposite over adjacent. So my opposite side is 1 and my adjacent side is 1. So Pythagorean theorem, a leg squared plus a leg squared is my hypotenuse squared. All right, so my hypotenuse squared then, 1 squared is 1. So my hypotenuse is going to be a positive or negative square root of 2. But remember, we don't have lengths being negative, so that's got to be the square root of 2. So that should pop in your head. Oh, I know what kind of triangle that is. That's a 45, 45, 90. Okay. A 45, 45, 90. So I built my triangle. All right. I found my reference angle. So my reference angle is 45 degrees, which is 180 divided by 4, pi over 4. Now my answers, remember, I had to have a quadrant 1 answer. And I needed a quadrant 4 answer. Well, in quadrant 1, remember your reference angle is your given angle. So in quadrant 1, my angle is 45 degrees or pi over 4. Well, now how do I get this quadrant 4 answer? Right, well, remember, you've got to go to that little formula. In quadrant 4, that reference angle is 360 degrees minus your given angle. All right. Well, your reference angle was 45. That's 360 degrees minus something. So if you want to put a variable there and do a little one-step algebra equation, that means that your angle is going to be whatever 360 minus 45 is, which is 300 what? 15 degrees. So I've got to know that this angle is going to be something times my reference angle. Remember what your reference angle was. Your reference angle was pi over 4 or 45 degrees. So what do you multiply 45 by to get 315? Couldn't you just take 315 and divide by 45 to find out? Isn't that going to be a 7? So I get 7. Remember, that's going to be pi over 4. So my other angle is going to be 7 pi over 4. Okay, so that's a pretty quick zip through review of some trig. So what I do expect you to know is I expect to be able to give you an angle and you find me the trig, the exact answers, like the cotangent of 7 pi over 4, or the secant of 5 pi over 6, or the cosecant of 5 pi over 3. Okay, so I would give you the angle and then you give me the trig value. So the other thing I'd expect you to do is be able to flip it. I could give you the trig value and you find me the angle. Okay, now what I did on that review sheet was this in the directions. And I don't remember how I did it. Theta. If I tell you that your angles are between 0 and 2 pi, that's like 0 to 360. And I do this and I do that. Remember what that would mean. A bracket means included and a parenthesis means excluded. That would mean start at 0 and go all the way to 360, but don't include 360. Now, if I did this, that would mean you would include it. So you need to notice, because I could write it, this is called integral notation, and this is called algebraic notation. So these two things say the same thing. Include 0, include 2 pi. Include 0, include 2 pi. This would be the same thing as that. Include 0, but do not include 2 pi. Do not include 2 pi. Now, the reason I do that is, you can just keep going around and around and around and around. You can have angles bigger than 360. So double check the directions, and I did that, so you only have to go around the unit circle like once. You don't have to have angles bigger than 360 for your answers. But if I give you the answer, what you think of as the answer, like the tangent of some angle is 1, and you give me the angles who have that tangent. So you build your triangle and then give me the ones that correspond to that answer. So if you need some help, come see me.